Detailed description of the invention. The following description is a preferred embodiment. The combustion gases are cooled and enter the combustion gases and particulates capture process. The bond of chemical compounds or unburnt fuels or large carbon compounds are broken by igniters with chemical bond breakers 1 within a magnetic field and the positively charged cyclone chamber 2 electrostatically positive. Carbon monoxide, CO, is electronegative and is attracted to the inner wall of the positively charged cyclone chamber 2 and a plurality of rotationally positioned superconducting magnetic coils 4. In addition, the at least one negatively charged tube chamber 3, electrostatically negative, repel the carbon monoxide, CO, which is electronegative. The angular position of the magnetic coils 4 is controlled by the at least one computational controller 7. Furthermore, the performance log and the global position of the system can be recorded to environment pollution control systems by means of the at least one communications device 8. The combustion gases and particulates spiral down the at least one positively charged cyclone chamber. The temperature is cooled down to -80 degrees Celsius by the at least one cryocooler 5, whereby carbon dioxide, CO2, begins to freeze and spiral down along with the particulates into the carbon and nitrogen compounds and particulates collection chamber 9. Being positively charged will attract the carbon monoxide, CO, which is electronegative, and the additional containment, superconducting magnetic coils 4. Moreover, nitrogen oxide, NO, nitrogen dioxide, NO2, are paramagnetic and therefore are retained by the magnetic field. The other gases flow into the at least one combustion gas liquefaction fractional distillation chamber 6, and a well-known process can be used to extract nitrogen, N2, oxygen, O2, argon, R by a well-known method called liquefaction and fractional distillation. In the liquefaction process, during the cooling phase, the combustion gas vapor condenses. Carbon dioxide, CO2, freezes at -80 degrees Celsius and is removed. Oxygen, O2, liquefies at -183 degrees Celsius. Argon, AR, liquefies at -186 degrees Celsius. Nitrogen, N2, liquefies at -196 degrees Celsius. In the fractional distillation process, the liquid at a temperature at -200 is slowly raised in temperature, and the different gases boil off and are collected during the fractional distillation. Oxygen, O2, boils off at -183 degrees Celsius. Argon, AR, boils off at -186 degrees Celsius. Nitrogen, N2, boils off at -196 degrees Celsius. Therefore, we are interested in capturing and containing the carbon dioxide, CO2, preventing dispersion into the environment. Furthermore, additional processing will extract the oxygen such that oxygen is released back into the atmosphere while retaining the carbon, hence completing the carbon capture process.